He needs his glasses back. They broke.
I'm pretty sure Friday 2 weeks ago.
I did not.
It takes forever to get stuff like that. It's crazy. Okay. All right, so.
You're flying too, you can't say no.
I will say that as a class, your class has the poorest eyesight of any class that I've had in a while. So. All right, so. All right. All right, so let's talk about mean value theorem. Mean value theorem tells us, this is your definition here, if f is continuous on the closed interval, a to b, and differentiable on the open interval, a to b, then there exists a number c in AB such that f prime of c equals f of b minus f of a over b minus a. Okay, sounds like nonsense. Okay, so f of c, or f prime of c, right, is the derivative, so that is the slope of f at c. Okay, close. Go ahead. No. Open does not include the endpoints. So you got parentheses there for A and B. Closed. Right. So it's not terribly important here.
The cure-all.
Do not drink the Red Bull. That is the opposite of what you should do if you have chest pains.
That's incredible, Tommy.
Okay. Okay.
Yeah, that was
right.
kind of rude, Tommy. I think Gaines
Okay. All right. So focus, because this is going to be a fairly important section. So the slope of the f at c is going to equal, what is this stuff? F of b minus f of a over b minus a. Okay, I'm hearing several people at one time. Alfredo, what are you saying? Good. So this is and that is slope formula, right? So that is slope between what 2 points? A, f of a, and b, f of b. Or, I heard somebody else saying something different with the word average.
Oh, average. Or average slope.
It's average, let's call it average rate of change. It could be velocity if it was like a distance, but it could be any rate, right? So the slope between the endpoints is your average rate of change. So in other words, at some point on the interval, the slope of the tangent line equals the slope of the line through the endpoints. So let's think about what that looks like on a graph. If we graph it, so let's say we've got, here's A, here's B. We've got, it doesn't even matter what this graph looks like. It could be anything. It could be a straight line, or whatever. So, right here, this is your slope through the endpoints, right? And so, there has to be at least 1 point. In this particular case, there's more than 1 point. There's got to be at least 1 point where the slope of the tangent is parallel. In this particular case, it looks like there's probably 2, which would be around those spots right there. But there has to be at least 1.
That's a cool shape.
It is kind of cool, isn't it?
So for about 5.2 million.
Yeah. Yeah. Okay.
Fun to Elkins for like the next 30 years.
Yeah. Okay. All right. Now this is a controversial problem right here. But it really helps me remember mean value theorem.
We had English.
Okay. So this was whenever I had Connor Nance, or no, was this Connor Nance or Trevor Nance? Trevor would have been the same year as Madison Shoemaker. Right? Yeah, it was this year. So I think it was the second year I taught calculus. No. Yeah, I think that's right. Second or third. So I've been using this one since then. Officer Nance and Officer Shoemaker are both waiting on the side of I-77 for speeders. They are 6 miles apart, and the speed limit on the entire stretch of road they are covering is 70 miles per hour. Okay. Officer Shoemaker sees a brand new Corvette pass her going 65 miles per hour. She calls Officer Nance to tell him to be on the lookout for the Corvette and gives him the tag numbers. Exactly 4 minutes later, the Corvette passes Officer Nance going 65 miles per hour. Officer Nance turns on his lights and pulls the Corvette over for speeding. Is he justified? What speed should he write the ticket for? All right, so let's consider. I said this was a controversial problem here.
I got very old, and I was actively going 65 miles per hour. And he told me from A to B your rate of speed.
We will go ahead and acknowledge that this is probably not going to happen, and that there would have to be a lot of documentation for them to prove it was definitely you, it was definitely that time period, it was definitely 6 miles per hour. Plus they might be targeting you for whatever reason, I don't know. But probably this is not going to hold up in court just because you're not going to be able to do all of that stuff. But if they could, without a doubt, prove that it was you, it was exactly 6 miles apart, exactly 4 minutes. Okay? So they can prove all of that. Is it justified, and what speed should they write the ticket for? So, let's think about what we've got here. Let's draw us a graph. Okay? So, we're going to put distance here in miles, and time here. Oh, not seconds. Okay. Okay. So it is easiest to let the point where you pass Officer Shoemaker be just 0, 0. You've traveled 0 miles in 0 minutes there. So the other endpoint here would be at 6 miles. You have traveled, I'm sorry, yeah, 6. Oh, wait. I tell you what. I really should have this the other way. Hello? Yes. Margaret, the phone is for you.
Uh-oh.
Huh? No, it's the nurse. Oh, she's a lovely lady. I like her. She's so nice. I tell you what. On second thought.
Margaret is like actively dying.
Let's change this.
You have COVID.
That's fine.
Good. Are you okay? No? Okay.
No, it just says red.
He doesn't even text me.
Okay. All right. So let's let's switch this because normally we put time on the x-axis, and I was not thinking. It will make our lives easier if we put time on the x-axis. So 4 minutes, 6 miles, right here. So we know this is the point 4, 6. So if we want to know the average speed here, then you could do slope formula if you want, 6 minus 0 over 4 minus 0. So you got 6 miles in 4 minutes, which is 1.5, right? Yeah. 1.5 miles per minute, but our speed limit is in miles per hour, so we need to adjust this. So 1.5 miles per hour. We would need to change our, I'm sorry, it's minutes right now. We need to change our minutes to hours. There are 60 minutes in 1 hour. And so if we multiply that there, we're going to get 90 miles per hour. Okay, so assuming that they could prove everything, and it would hold up in court, then the average speed of this car had to be 90 miles per hour at least once. And considering we know that he was going slower than 90 miles per hour at the 2 endpoints, that means he was going faster than 90 miles per hour sometime during the course there. So this person was not only speeding, they were speeding a lot. So, yeah, they probably have something that's telling them that the cop is near. So, yeah. So they have something that's telling them the cop is near, or they just saw them and slowed down before they could, radar them. So anyway, this car had to have gone at least 90 miles per hour. So assuming that they could prove everything in court, they would be totally justified in writing this person a ticket for 90 miles per hour in a 70 mile per hour zone. At least. It was probably higher than, it was definitely higher than 90 at some point. Average speed was 90. And this is called the mean value theorem. Mean means average. So it's saying that the average rate of change over this time period has to equal the instantaneous rate of change at some point. So there had to be some point here where he was going 90 miles per hour. Probably 2 points where he's going 90 miles per hour because he was going slow. He had to speed up. He had to get over 90. Yeah, possibly. Yeah. So, anyway, this person would deserve his ticket. Or her ticket.
No, calls that baby numbers. I do. Huh?
No, driving is super dangerous, and you need to drive like you got some
The
sense.
Jeep can't speed.
Huh?
The Jeep can't speed.
It's like 1.00.
We'll be speeding again.
How many tickets do you
Yeah.
have?
I pulled over twice when I did tickets on the record.
Sick.
I beat that case. That's right.
I got a clean record, and I need it for the. So I don't know. Somehow the recruiter says like any tickets or that
Because I beat that case.
Like
Yeah. Tickets are probably fine unless you have lots of them showing that you're crazy.
Yeah, you 1 or 2 is acceptable, but anything more than that's kind of like.
My husband used to have to go to these fatality meetings where they reviewed every fatality, and it was like several counties that were on the road. And he said that well over half were people who were doing something dumb, like going 100 miles an hour. There were you can always have an accident where it's just an accident, you weren't doing anything crazy, but he said well over half were either drunk on drugs or going 100 miles an hour. So, you should not go 100 miles an hour. If I had time, and I don't, but the mother in me needs to tell you this, Noah.
No, my mom tells me enough, don't worry.
We do this in math too, or used to. Stopping distance is not linear. It is more of like a quadratic sort of equation. We use it with quadratics. And so the faster you're going, the longer, like big time longer it takes to stop. If you're going 100 miles an hour, it's going to take you like several football fields to stop. Depending on your car and your tires, and there's so many factors there, road conditions. But I mean, it is true. Like this Corvette's probably going to stop a lot faster than a truck. So there's a lot of factors there, but either way, it's not going to stop as quickly as it would if they were going 70 miles per hour, which is the speed limit.
See, good drivers don't have to stop. No,
oh my. Okay. All right, now. All right. I like this problem because it helps me remember mean value theorem. And whenever we go past this and you've forgotten mean value theorem, I will tell you to come back to the speeding problem to think about the mean value theorem, right? So let's talk about what you have to do to justify this as far as mean value theorem goes, okay? So mean value theorem, you have to show that the function is continuous on the interval and differentiable on the closed interval. So you would have to start off by saying, like, let's just call this function, I'm going to call it, let's see, it was going slow. So it needs to look like this. Maybe, it needs to be slow here, fast, and then he's got to slow down again. So it's got to look something like that. So let's call this, we'll just call it f of x. He was not going at a constant speed because they clocked him at 65 miles per hour at both endpoints. So he had to have accelerated here.
Yeah, what if he just jumped 2 miles?
Yeah, so that is actually kind of a good question here. If teleportation was possible, they could not write him a ticket because the function would not be continuous, right? So it would not be continuous. But let's go with this universe. Correct. If he can prove teleportation is possible.
Technically, he could set his clocks 2 minutes behind in the car to say that he went through time.
It won't work because we're going off the officer's time.
Well, I know, but like his time, their time stays the same, but his time.
That would be part of his story. Yeah, he would need to do that. You're right. Yeah, because I think whenever.
I feel like legally created your name to Marty McFly, you should be able to teleport. Oh, I said that if you legally change your name to Marty McFly, you should be able to teleport.
Okay. All right. So,
Same thing.
science. Can't question that. All right. So, what we have to say here is we have to say that f of x is continuous on 0, 4, and it must be differentiable on 0, 4 with parentheses. It is okay to just say it's continuous and differentiable on the closed interval. So it would be, I'm just going to put it like over here to the side. Or we could say f of x is continuous and differentiable on 0, 4. Because in this particular case, it would probably be, and in most cases you're going to see it's continuous and differentiable on the closed interval. If it's a graph problem and it's not differentiable at the endpoints, if you have some sort of like sharp turn, then you would have to say it separately. But most of the time you can just say this together. Okay. So we are assuming that this is continuous. It is also differentiable because in a car, as you speed up and slow down, you're not going to be able to cause like your speed to go from 65 to 90 immediately, right? It can't change. It's going to have to gradually. Even if it's like in a Corvette, it can be a pretty sharp turn because they take off fast, right? If you're in the minivan, you're not going to have anything even close to a cusp there. But even in a Corvette, it might look kind of sharp, but it's not going to be a sharp turn.
It's not going to
right?
be a 90 degree.
No 90. Right. If you have a cusp, it is not differentiable. So we can assume that because of what we know about this situation. A lot of times you have equations, so you can assume that as well. So if we find f of 0 equals 0, and we know f of 4 equals 6, and we can say that f of 4 minus f of 0 over 4 minus 0 would be 6 minus 0. Sorry.
I mean, this should just be.
Sorry about that.
Why would you say that?
So excited to eat.
1.5 miles per minute, which I'm going to go ahead and change to 90 miles per hour.
I got like 3 more hours before I need. I got way in 5.
Is that what it was?
Yeah.
You're going to shout out after.
Exactly.
Okay, so, alright, so what you do is you're going to find the coordinates of the endpoints if you don't already have them. You take the slope between the endpoints. This is your average or your mean rate of change, your mean value. And you're going to say since, or we'll see,
So many words.
since, hold on a second. No, we don't say since. That's more like, that is a 1.5 miles per minute. I know, I'm sorry, there's not enough room here.
You know, I forget.
So we would say, therefore, the mean value theorem guarantees that f prime of x equals 90 miles per hour at some x on the interval from 0 to 4.
So the wording is kind of similar to intermediate value.
It is. And so you can kind of see like why you might get them confused, right?
Yeah.
But with intermediate value theorem, we're just saying that the point is somewhere between the two values. Here, we're saying that the slope through the endpoints has to have that derivative somewhere. It's the average rate of change equals instantaneous rate of change, because this f prime of x is your instantaneous rate of change. Right, so that's your speed, like if they're shooting you with a radar gun at that moment. Your speed has to be 90 sometime on 0 to 4. Okay, so let's look at a problem that you are going to see for this that doesn't have any context with it. Okay, so given the function f of x equals x minus 3 squared on the interval from 0 to 4, find the c value that satisfies the mean value theorem. Okay, so for this one, they're telling you to use the mean value theorem. You're not having to prove the mean value theorem, so you don't have to tell that it's continuous or any of that stuff here, because it didn't ask you to prove. So with these directions, I would say yes. If it said, does it apply and find the c value, then you would need to prove that it applies. So for it to apply, as long as the function is continuous on the closed interval from a to b and differentiable on the open interval, then mean value theorem is going to apply. So the only thing you have to have here, really, mean value theorem applies to every continuous and differentiable function. So x minus 3 squared is continuous everywhere. It's also differentiable everywhere. So this applies in this particular case. Because they're just asking us to find the c, we don't necessarily have to write that on this one. But what we want to know is we want to know the average rate of change, right? So average, or I should even call it mean, since this is the mean value theorem, rate of change is slope through the endpoints. So I need to find that average rate of change first. So I would find f of 0, which would be 0 minus 3 squared, which is negative 3 squared, which will give me 9. So one of my endpoints is 0, 9. And I would find f of 4. So 4 minus 3 squared would be 1 squared, which is not 1. So I would get 4, 1. So those are the coordinates of my two endpoints of this interval right here. And I'm using 0 and 4 because that's my interval. So I'm going to find the slope between those endpoints. So 1 minus 9 over 4 minus 0 is going to give me negative 8 over 4, which is negative 2. Correct. And it tells us on the interval 0.
Right. C equals negative 2.
C does not equal negative 2. Okay? So this is my average or mean rate of change.
Do you have to label it?
No, but I'm trying to. Is hold on just a second, I'll show you what we'll do. Average rate of change on 0, 4. You don't have to label that necessarily here, but I just am trying to be very clear what's happening. So what the mean value theorem tells us is that f prime of some value, I'm going to call it a c because they called it c up here, has to equal negative 2.
C is just interchangeable.
Yeah, you could use an x, you could use any letter there, but they used a c.
So like same thing as saying f prime of x, or like when you prove it on when you're getting graded, you have to prove that the average rate of change, and you say that f times c equals that.
Yeah.
Okay.
All right. So f prime of c is just the derivative of f of x, right?
Yeah.
So what we want to do is we want to find what that value actually is. So if we take the derivative of x minus 3 squared, that's chain rule, 2 times x minus 3 to the first power times the derivative of the inside. But what's the derivative of the inside? It's just 1. So essentially you just got 2 times x minus 3 equals negative 2. So you distribute that 2, or you can divide it off, either one. 2x minus 6 equals negative 2. Add your 6. 2x equals 4. So x is going to equal 2. I used x's the whole time instead of c's. I should have used c really, but I'm sorry, not negative 2. C is 2. So what this is finding, that's the x coordinate of the point where this happens. Right? So your f prime is just using your chain rule to find your derivative. So if it asks you to find that c value, you take your average rate of change and you set it equal to the derivative, because the derivative gives you instantaneous rate of change. So to find, yes, c, set derivative you can be exempt from the exam in December. Yeah. So you can take it if you're gonna take it to bring your grade up, but you can be exempt from it. So most of you will not have to take it, possibly none of you. But
all theoretically not take it, but it'd be beneficial to take it. Some of us.
okay. All right, let's try another problem. Okay, now that last problem said mean value theorem. Another thing you see a lot is problems that don't tell you it's the mean value theorem. Okay, so this says given f of x equals 5 minus 4 over x, find all values of c in the open interval from 1 to 4 such that f prime of c equals f of 4 minus f of 1 over 4 minus 1. So they do give an open interval here, but is this still continuous on the... Oh, is it? Yeah, is this still continuous on the closed interval? Where's the only place this is not continuous? 0. So it would still be continuous on the closed interval here, so it's okay. So they're not telling you that this is mean value theorem, but the derivative is equal to, what's this stuff right here? This is your your average rate of change, right? So this is your slope through the endpoints. So this is mean value theorem. So you're going to find what this equals right here. Okay? So f of 4 is going to be 5 minus 4 over 4, which will give us 4. And f of 1 is 5 minus 4 over 1, which will give us 1. So we are going to have... Okay, I am plugging into the function that they gave me up here. So what I'm doing here is I'm finding those points. So this is the point 4, 4. And this is the point 1, 1. So if I do slope here, I'm doing 1 minus 4 over 1 minus 4, negative 3 over negative 3, which is 1. So all of this stuff right here equals 1. So f prime of c equals 1. They're asking us to find c. So we got to plug in the derivative right here. So first let's find the derivative. I'm going to write it like this. Instead of doing 4 over x, how could I write that? 4x to the negative 1. So f prime would just be 4x to the negative 2. Or 4 over x squared. So we want to know where this derivative, I'm going to use the c this time, that would be better, but you could use, if you use the x, just say it's a c at the end, it's fine. How do I solve that? So, multiply both sides by c squared. That'll get, because anytime something's in the denominator, you got to get it out of the denominator. So 4 equals c squared, square root both sides. It's technically it's a plus or minus 2, but we're only looking on the interval from 1 to 4, so c is going to equal just the positive 2. Here. So we found the slope, and it was 1, so we have the f prime of c is going to equal 1. So the derivative we found over here, that's our f prime, right? 4 over x squared. So I used the c right here. If you use the x, it would be okay. You're taking your derivative, and you're setting it equal to the average rate of change, which is that slope that we found. And so, since the c is in the bottom, you cannot solve for the, because it's 4 over x squared. So it'd be 4 over c squared. If you want to use the x instead, that's okay. Yeah. I changed it to a c just because they say c in the problem, but, and then you just solve. Okay, questions? So I plugged in, the endpoints to our interval right here are 1 and 4. So I just plugged those into the function. So when I plugged in 4, I got 5 minus 4 over 4, which is 4. So that point, the x I plugged in was 4, and the number I got out was 4. So that was the point 4, 4. And then when I plugged in 1, I got 1. So that was the point 1, 1 here. So those are the points I use to find my average rate of change. Yep, slope formula. Okay. All right, so the table below shows certain values for f, a continuous function. Change that. That needs to be differentiable. If it is differentiable, it has to be continuous. So a lot of times it won't say continuous, but it has, yeah, it has to be continuous there. So
like an FRQ, can we say it's just differentiable to understand that?
To be safe, I do not 100% know the answer to that question.
That'd be kind of weird if we had to know that problem.
So this is just where I messed up on the problem, because if I only told you it was continuous, you couldn't use mean value theorem. So it should be differentiable from the beginning. So it's asking us if there is a value on the interval from 0 to 10 such that f prime of x equals 1/2. So in this case, we've got an interval, we got the derivative equal to something, so that should have us thinking mean value theorem. So we want to know if the average rate of change is ever 1/2 on any of this graph right here, then there has to be a time when the derivative is also 1/2. So it usually is actually the endpoints. Technically, if the slope between 0 and 2 is 1/2, or 0 and 5, or 0 and 8, or 2 and 8, between any 2 points on this graph, the mean value theorem would apply to this situation. But usually, they're going to give you the endpoints of the graph. So if we use the endpoints here, let's see if it works. So I would have the point 0, 5, and 10, 10. So if I do 10 minus 5 over 10 minus 0, I will get 5. Gosh, I don't know what's doing that. Over 10, gosh, it's awful. Which is 1/2. So the slope between the endpoints on this graph is equal to what they're telling us the derivative is going to be. So it does have to be true that the derivative has to equal 1/2. So let's look at what we have to show to prove that. So the first thing, I'm going to number them just so that you can kind of think of the things that you've got to show. So the first thing you have to say is that f is continuous and differentiable on 0 to 10. It tells you that it's differentiable, which means it also has to be continuous. So I think you're okay just stating this right here. If I'm incorrect about that, then it would mean you need to say, since f is differentiable, it is continuous. Therefore, f is continuous and differentiable on 0 to 10. But I don't think that would be required here. All right, so you first have to show it's continuous and differentiable, because if that is false, then mean value theorem does not apply. Then you're going to say, well, let's see. The second thing you definitely have to show is you have to show what the slope is between those endpoints. So I'm going to put that. Oh, it's out of order. These out of order. Then we have to say by the mean value theorem. And basically, after by the mean value theorem, restate the question. There is an x value on the interval 0 less than or equal to x less than or equal to 10, such that f prime of x equals 1/2. So, continuous and differentiable, show the slope through the endpoints, mention mean value theorem, and restate the problem affirmatively. Okay, questions? All right, one more here. Function f is graphed below. What is the average rate of change of f on the interval from 1 to 5? So, average rate of change, slope through the endpoints. You can just see it from this graph. What is it? No change at all, so it is 0. All right, so if you have one like that, it would be okay, I think, to say that without showing the slope formula. All right, so this one does not ask you to prove any mean value theorem or anything. It just says, how many times on the interval from 1 to 5 does the average rate of change equal the instantaneous rate of change? Okay, I'm hearing 3. Instantaneous rate of change. What does that mean? Slope of the tangent. So, somebody give me a point or x coordinate where. All right, at 2. Right there. Tangent would be horizontal there. At 3, I would have a horizontal tangent. And at 4. Zero is your average rate of change. So it's asking how many times on the interval does the average rate of change equal the instantaneous rate of change. So average rate of change is this line right here.
Yeah, I got that. But like, I'm confused on why instantaneous is 0 and the instantaneous is 1 looks like it goes.
So instantaneous at 1 is a positive slope. Right. So what we want to know is how many times on this graph do we have another slope that or tangent line that would be horizontal. Here. So, and it's at these places where we have like maximum or minimum points. So, no. No. If it were, we wouldn't have enough information. We know it's positive, but we wouldn't have enough information to answer that. So, it wants to know how many times. It is 3 in this case.
We don't need to prove either one of them.
No, not for this. These are usually going to be multiple choice questions. Like this. Okay.
It's not. It's like a FRP.
I will tell you really quickly, in case I didn't take everything off of here. So, your assignment tonight comes from Mr. Record, and Mr. Record teaches Rolle's theorem. Rolle's theorem just is basically like this last problem. If you have 2 points here where you have a 0 slope, then you obviously have to have a 0 slope somewhere in between. It's essentially just like a special case of mean value theorem. They do not test Rolle's theorem, and it's just a special case of mean value theorem. So this is still mean value theorem here. So, but if you see Rolle's theorem somewhere on the homework, because I think I took everything off, but I may not have, especially on the key, just know that we're going to use mean value theorem instead. Okay? No. Because I've warned you about it ahead. So,
Actually, not really.
are y'all wrestling here or?
When it is here, I'll let everyone know so they can come see me.
Okay.
It'll be. I'll tell everyone needs to come to my senior night. I got you. This is the only senior on the team. Are you?
Yeah, we need to